My activity involved taking students outside with two pieces of black paper and a magnifying glass. Using the sun's heat, the purpose of the activity was to demonstrate to students how the black paper absorbs heat with the aid of the glass. For this activity, interactive modelling was the pedagogical approach that I used. I modelled each step of the activity by verbalising and guiding students how to complete the task, while still allowing students to participate, ask questions, theorise, and observe the experiment. By using the interactive modelling, I found that students were excited and eager to see how the paper reacted to the sun's heat and engaged throughout the lesson. I found that it assured confidence in the students as they asked many thoughtful questions, like if the paper heated faster on one side due to the texture of it, or if we would get different results from using different coloured paper. It also allowed for understanding on what they could expect from the activity, as I was able to break down the activity into smaller chunks. This meant there was little confusion on the task and allowed them to focus on the concept of heat transfer. It also meant that by me modelling the activity, students gained immediate clarification and understood the objective. During the lesson, I had students holding the magnifying glass to the paper for 30 seconds and then passing the paper around to the group to see if they could feel a heat difference. By doing this, however, we found that it wasn't long enough for the students to physically feel a dramatic temperature rise on the paper. This led to a slight disengagement towards the end of the activity. To modify this activity in the future, I would extend the time the magnifying glass is on the paper and add different coloured paper to the activity, such as white, pink, and grey, just to add some variety to the lesson. This would also allow students to understand that certain colours absorb and retain heat more so than others. I would also incorporate the use of a digital thermometer. So while students may not physically feel a heat difference, the thermometer would visually aid students in seeing the temperature rise. And lastly, for this activity, it would be great to have students working in smaller groups so they could work collaboratively. It would also mean that students could voice their opinions rather than having the same few students volunteering information. Overall, I think this pedagogical approach to this activity worked well.
In our first lesson, we implemented science journals as a pedagogical approach to support student learning. Science journals provided students with a structured way to record their observations, predictions, and reflections, helping them develop scientific thinking and reasoning skills. By writing in their journals, students were able to document their thoughts in their own words, reinforcing their understanding of the scientific concepts and predictions made based on our activity of evaluating which object got hotter when placed in the sun, the metal spoon, or the plastic cup. Using science journals allowed students to engage actively with the lesson and develop their prediction and reasoning skills. Many students made their predictions based on prior knowledge as seen in responses from numerous students, such as, I predict the spoon because it's made out of metal, and I predict that the spoon will get hotter than the cup because metal gets hotter than plastic. This approach also encouraged ownership of learning as students took responsibility for recording their observations. Additionally, writing in journals supported literacy development by strengthening sentence structure, expanding scientific vocabulary, and improving students' ability to communicate their ideas clearly. The journals provided an opportunity for reflection and consolidation, allowing students to compare their predictions to the actual results at the end of the lesson. To improve future lessons, we plan to implement several modifications. One key adjustment will be providing sentence starters on the board to support the students who struggle with grammar and sentence structure. This will help ensure that all students can articulate their observations without feeling left behind. A couple of our students did feel a little left behind, so this is a key one that we want to implement. Additionally, we will introduce timed writing segments to set clear expectation and maintain lesson flow. Another strategy will be to think, pair, share before writing. This allowing students to verbalize their thoughts before putting them into words. This will also help students who need additional support in organizing their ideas. By making these modifications, we aim to enhance student engagement and ensure that all students can effectively use their science journals to support their learning throughout our time.